Okay, so we have been talking about inheritance last time, if you remember, and we had this example about rubber lines. For some reason, we were not able to get it to work with mouse events. So if you recall, we had this implemented using mouse pressed, and then for some reason it didn't work, or mouse clicked. However, I tested it with the code at home, and it seems to work. I don't know what we have done differently last time, but maybe somehow we missed something there. So you can also, if you want to go ahead and implement, you can implement this too. And I recommend you to try and test the code and see if you will be able to write the same code. And it will give you more of a practice chance. So you can go ahead and see that. If you need to get that, you can, you can contact me, and I can send you the files as well if you need to. Just one reminder about the class. The final date is set, so they have announced the final dates for the summer semester, and our class is going to have the final during. So let me open that up, and I posted this on the web page as well. On the recent announcements, you can see that. So as you see, the final will be held on Tuesday, July 27th, and it's going to be in rooms EB 101 all the way to 204. And then also the midterm rooms have been modified, so I have updated that too. If you go ahead on the web page, you can see that the rooms of the midterm will be in this building, so we will have the midterm here on Monday, July 5th. So you have less than a week from today. So you should, if you don't have the necessary background, you should start immediately working on the CS 101 topics if you feel you're lacking those things. So definitely there will be questions related to the CS 101 topics, which we assume you already know. So you will see array questions, loops, nested loops, and object accesses, such as in the methods. What happens if you pass an object? What's going to be modified? If you recall that example we did with the numbers 101, 223, and 333 initially assigned, and then we updated the values within the objects. If you recall the number class, right? Do you remember? We had the number class, which was keeping only an integer value versus an actual, primitive data type of an integer value. So these type of questions may come, in the exam. So you should know what happens with an object if it is passed to a method, or if it is, accessed by a certain other class. So you should know all those details. And also, whatever has been covered in the class, you will be responsible for that part too. So if you need, more clarification on things, you can contact me as well. But you will be responsible for whatever you have covered so far. Any question about that? Again, if you have, if you have things to discuss, we can do that offline as well. So we will continue, apart from this, reminder, I will continue the discussion on inheritance today. So if you recall, we said that inheritance aims to actually utilize a class that has been previously, used and implemented. In this case, if you have a vehicle class, you would like to use its methods and functions and available properties such that you implement the car easier than basically implementing it from scratch. So that's the basic idea behind inheritance. So if you have thousands of lines of code, you would like to utilize them by inheriting the class properties with the newly created classes that you have. So in inheritance, we have a child class or a subclass that is implementing the parent class or the base class. So we have the base, and then we have the the child class that we are using, or you could say parent for this one too. So by using this existing implementation, you can implement additional methods that are not available for the base class, but that will be possible for the child. So as we said earlier, class car extends, vehicle extends is the keyword that we use for inheritance, and that's how the car will be inheriting the properties of vehicle. And you will be, we have seen this example, so I'm not going to go into details, but if you recall, we had the book that's defined as a base class, and then dictionary was inheriting its properties, or maybe let me just open it briefly and show it to you, so that the next example will also be dealing with the same class but in a different way, so it will be a good base, good starting point as well. So let's go there. So basically you had the book class, which is, which has public class book, and then you have the pages initially set to 1500, and then you have a set method which sets the, the instance variable pages into the given argument, and then you have a method which basically returns the number of pages. So this is a basic class which doesn't have anything really interesting. It just keeps track of the number of pages initially assigned to 1500, and then the extend or the child class of this book is dictionary class, which extends book. So it basically uses the available instance variable to book, which is the number of pages, 1500 initially. So it has that variable. On top of that, it adds more instance variables such as the definitions. So you have 52,500 initially set to the instance variable definitions whenever this is created. And then you have, in addition to those get methods, you have get and set methods for the number of pages for book. I have these additional methods. So I have compute ratio, which is going to just return definitions divided by pages. Remember, pages is not part of this class, but it's part of the base class. So you can access it easily by calling it. How is it possible to access? So if we compile this, it should give an error, right? Yeah. As you see, pages has private access in book since we have modified it yesterday. So I will just go ahead and update it as to be protected, right? Such that now it's going to be possible to access it from the child class as well. So if you compile it now, it should work fine. So we can access this pages variable since its parent class has this defined as a protected. This was the keyword, if you remember, that that's the modifier that indicates the visibility modifier that indicates it's available to the package, which includes the subclasses of the parent class. And then you have other, set definitions and get definitions, which are the also primary methods for the subclass or the child. So this, structure is the general implementation. You will have parent classes, methods, and instance variables, and on top of that, you will add additional methods and also additional instance variables that are only specific to the child. So that's the general structure that you should aim for while designing your application. And then this words application basically creates a dictionary Webster, and then it creates the dictionary object, which is a dictionary object that's based on the book class. And then whenever you call the get pages, which method is it going to call here? The parents method, which is the get pages available to the parent. And then whenever you call the get definitions, it calls the child's method. As we will see, overriding will enable implementing the same method on the child as well. We will see how it is done and what is the outcome of such implementation. When you call compute ratio, this was, if you remember, the method of a child class, which is part of the dictionary. This compute ratio will be called from the child class. Any question? So as I said earlier, we already covered this, but just to remind, protected enables to access the instance variables from the children of the or the subclasses of the parent class by using that modifier. So if you need to have it accessed, you should declare it as protected. The reason why we do not define it as public is because, as you all know, it violates the encapsulation, so you don't define them as public, and you tend to declare them private. If it is needed, you declare them as protected. Otherwise, unless, if it's not a constant, you shouldn't go for the public declaration. So in UML, this is the description of the class that we just mentioned. So you have the words class, which is basically using the dictionary class. This was what this arrow was indicating. And then you have the definitions, which is a private variable of integer type, and then public definition message method, which is a void method. And then you have the page message, which is again a public method, void. And then you have number. What does this indicate? This indicates the protected modifier. So our pages variable is a protected variable, and its type is integer. So this is the UML description of the classes that we had in the example. And when you look into the super reference, we have seen the super reference before in the context of graphical user interface components, if you remember. And the main thing that we used this for was, if you remember, we called it with super. We had this super.paint component, right? The idea was, if you recall, I was saying this because we were calling the super component, which was usually the JPanel, that we are calling the paint component method. And then it was establishing the panel and painting it on the screen. On top of that, after we called the parent class, we were adding the necessary stuff after this. So super basically calls the parent class and then refers to the parent class and accesses the methods or the constructor or whatever is needed will be used by the super reference. So if you need to refer to the parent class, you use super. And let's see this example. This will give it a more clarified view. So let's go and check that out. Book 2, dictionary 2, and then words 2. So if you go here in the book 2 implementation, again we have the public class book 2, and then I have the protected in pages. Book 2 has its constructor. This is different from book, if you remember. It didn't have any constructor at all. However, in this case, it has a constructor which takes the integer argument and assigns it. And then you have the set pages and get pages method as before. That's same exact, no differences at all. And then if you look into the word dictionary 2, you see that it extends book 2 now. So it's going to use the methods available from book 2 and also implement some more. And it has the private instance variable, which is definitions. And you have public dictionary 2 constructor, which is basically instead of the main or the base class constructor, it takes the number of pages and number of definitions. So what does it do? It calls the super num pages. Why is it calling this? So for every child constructor, the first thing to do is to call the parents constructor, such that you have the parent class started and initialized to the respective values, and then afterwards you do additional things that you need to do after that. So before you create your parent class's object, you cannot create the child objects part. So you have to. The first thing that you have to do in a child constructor is to call the parents constructor. So that's what is going to happen here is that it's going to call the super, which is in this case book 2, book 2's constructor with the number of pages. So basically it's going to call this book 2 and its constructor, which is this. So it's going to set the protected variable pages to the given pages. So this, as you all know, pages is not part of this but parent classes. So it's going to initialize the number of pages to the pages. And definitions will be equal to the num definitions, which is passed as an argument here. Okay? So, for example, if you get rid of this constructor, what's going to happen? So if I eliminate these. So I no longer have a dictionary to constructor. What do you think is going to happen? It's going to give you an error because you have a constructor that's, by default, you have to call this constructor in order to create your object. So you have to call one of the constructors. However, before you initialize this object, the parent object, in order to have this object created, you have to have the parent object first. So it doesn't exist, in which case it's going to give you an error. So you have to, if the parent class's object is there, its constructor is there, you have to add that too, and then implement it according to the needs of the class. So basically, without this constructor, you will have an error. And if you go here, the rest of the implementation is same. Basically, you return the definitions divided by the number of pages, and then set definitions and get definitions are all same. The only difference is that with the constructor, so again, if you have a child constructor, you have to first call the parent constructor before initializing your internal instance variables to the respective values. Okay. So words 2 basically is going to do the same thing. It's going to create dictionary 2 with the respective arguments. Since in this case we have 2 arguments for the constructor, it's going to basically have those and then print all those methods as we did before. So the super reference is, important. A child's constructor is responsible for calling the parent's constructor. So whenever you have a child, you have to call the super. The first line of a child constructor should use the super reference to call the parent's constructor. The super reference can also be used to reference other variables or other methods of the parent class. So if you, let's say there's an add method by that is part of the parent class, you can call this by super.add. So you can call the parent class's methods by using the super identifier referring to the parent class of your class. So multiple inheritance. Is multiple inheritance provided in Java? Anybody knows? Or which languages provide multiple inheritance? C++ provides multiple inheritance. First of all, what's multiple inheritance? So let's say I have a class that tells me, that gives properties of a human. So I have a class that identifies a human being. And then let's say I have another class that identifies a worker. Okay. And then I have another class that identifies musician. So, whatever internal representations you may have within these classes is not really important. But you have all these classes declared. And then let's say you have a street musician. Basically earns his life by working as a street musician and gets money from the people on the streets. So basically this street musician is a human, right? He or she is a worker also, and he or she is also a musician. So she has all the properties of all these classes. So she's going to be sharing all the properties, all the methods, whatever they have in these classes. So this is called multiple inheritance. It's not inheriting the properties of a single class, but rather more than one class, and that's called multiple inheritance. However, in Java, multiple inheritance is not provided. In C++, it is provided. If you want to implement things in multiple inheritance, you can go ahead and do that in C++. However, in Java, it's not provided as a base toolkit. There are other paths to try to implement multiple inheritance, but they're not really supported and recommended as well. So if you want to go ahead and see the details of it, you can search for that, and also I can have show you pointers if you like. But in general, multiple inheritance is not provided in Java. That's what you should know at the moment. As I said earlier, multiple inheritance allows a class to be derived from two or more classes inheriting the members of all parents. So this creates collisions and problems in same methods implemented in human and worker, which one is going to be selected and how. Things like those complicate things, and Java chose not to implement multiple inheritance at all. So it is just an implementation choice. However, in C++ they have chosen to add that support too. But again, what you have to know is that multiple inheritance is not provided in Java. So overriding methods, this is one of the key things in inheritance. Once you have a method that is declared in the parent class, so let's say I have a musician and then also let's say a street musician, and if there's a certain method that is implemented within the musician and I'd like to modify my own version of the same method, that's what we call overriding. So this parent class has a, let's say, toString method that is written in some way, and then I'd like to have my own method that will implement street musicians toString. So I will have the toString method that's going to basically override whatever has been implemented here. If I have it in the child class, that's going to override all the methods that I have here. So it's going to basically call, whenever I call the toString method, it's going to execute this child's method, not the parents. So that's what we call with the overriding. So the new method must have the same signature as the parent's method, but can have a different body. So you have the same signature, however, the implementation, obviously, that's the reason why you implement it differently, right? That's why you override it. Probably you want to have a separate implementation. So you have the same signature, but a different implementation of the same thing. So the object of the executing method identifies which version of the methods, two methods will be used. So let's say I have these messages, taught and advice. So let's go. Advice, messages, and then taught. So if you look into here, I have the messages class, which is the running class, which is going to execute the application, and then the base class is taught. So basically you have public class taught, and then only a void message basically prints a string on the screen. So it has the message system out print line. I feel like I'm diagonally parked in a parallel universe, and then you have the additional system out print line statement there. So basically this is the base class, and then advice extends this. Public class advice extends taught. How does it extend it? It modifies the message that has been implemented in the parent class. Remember, it was the message method as well. Now this method is also message. So whenever I call this advice objects message method, this will be the one that is going to be called. So what is going to be printed? It will print this: warning, dates in a calendar are closer than they appear. And then after that I also call the parents message method. So basically it will print that, and then it will call the taught, which is the parent class, because I have the super. It's going to call the taught class and then print this message on the screen after my own message on the child. So when I have this running on here in the messages, so as you see, public static void main, and I have the two variables, taught, parked, new taught, so I create the taught object, and then advice, I create the dates, new advice, I create that object too. And parked message and then dates message. The first one will basically, since it's the base class, it will call the base class's message method. However, the child, which is the dates, an object type of advice, is going to call the message method of the child, and will have both of those statements executed and shown on the screen. So as you see, the first one basically writes the main parent class's message, and then the second one first prints the string of the child and then calls the super.message method for the parent class. So that's basically how it is going to execute. Any question here?
Hocam bu advice klasındaki super.şeyini yani overriding'de zorunlu olarak yazmak zorunda mıyız? Her override yaptığımızda.
So the question is, what if I just remove this line, right?
Evet.
What do you think is going to happen? It will perfectly run fine without any problems, right? It's basically, additional thing that is included here. You don't have to call that super. Again, the super is, necessary when you are calling the constructor, because you have to construct the base parent class after you can continue on. However, in any other method, you don't really need to, call the method. If you need to, you can, but it's not necessary. In this case, they just added this, how you can call the parents' other methods by using the super, identifier. So if I compile it like this and then execute messages, basically I will have the I will just get rid of the second line in this case, right? So if I execute this again, so as you see, this line is not repeated again because I didn't call the parent class, the super class's message method. Any question? So this is basically the overriding and how you implement override on a parent and child class relationship. So when you look into overriding, if you have a method that is declared as a final, it cannot be overridden because you can only override a method that is declared as if it is not final. So if it has the final modifier, you won't be able to override it. So it will be the basic implementation, whatever is provided by the parent class. Also, you can have the variable overriding, but this is not really recommended because it complicates and causes unnecessary confusion in the code. So you can, although do that, you're recommended not to override the instance variables and variables that you have. This is called shadowing variables. So, but again, you're recommended not to go into that path. Overloading versus overriding. What was overloading? So in overloading, if you remember, we implement the same method with different signatures within the same object. So if I have a class declaration, class definition, I call the same method. Let's say I have an add method, overloading. So I overload its meaning. I add more meanings to the method. I have add, and then I have a, let's say, integer signatures. However, I have another method which takes, an overloaded method with a different signature. Again, the signature was, if you remember, the number of variables and their types identify the signature of a method. So this is overloading. Again, this is within the same class. So this is within the same class. However, in overriding, as we did before, you have a parent and then child relationship, and you override the method that is available from the parent. So you rewrite the method over again. Okay, this distinction is important. You have to be aware of the difference. So overloading lets you define a similar operation in a different ways for different parameters, whereas in overriding, you have two different methods for the parent and the class. Parent and the child. So overriding lets you define a similar operation in different ways for different object types, such as parent and the child. Obviously, you can have multiple levels of inheritance. Let's say I have a class that is, inheriting from another class, which inherits from another class. So if you have an overriding method, that's going to override all the previous implementations, and the one that is implemented by the child will be used by that. So the parents methods will not be used at all. If you have multiple, implementation of the same method overridden by different levels. Okay. So you can come up, as I said earlier, come up with a class hierarchy where you use previously implemented classes before. So if you have a business, you have a retail business and a service business, which are both businesses. And then you have Kmart and Macy's, which are both retail businesses. And then Kinko's is a service business. So you can have this type of hierarchy and tree structures in your implementation. So it's usually the way you should be writing your codes and applications, and also in your project you should try to follow this structure. And the good a hierarchy can be designed by moving the common things as high as the on the tree, right? So if you have, let's say, a business manager that is available in all of these, you would like to have it implemented within the business class, so that it is available to all the inherited classes from that point on. Or let's say if you have a service business, and there's a certain property for the service business, you would like to have it here, not here, because it's not going to be common for this part of the hierarchy, and you will just add additional unnecessary stuff onto your class. So you would like to move things as high as possible. However, if they're not necessary in the rest of the hierarchy, you don't want to do that. Any question? So if you have two children of the same parent, they are called siblings, as the word indicates. And then, as I said earlier, you put the common features high in the hierarchy as possible. And then if you have an inherited member, it will continue down the line to all the rest of the members of the children. And if a child class inherits from all its ancestor classes, so in this case, in this example, as we just saw, Kmart will inherit the properties of the retail business, and then also the business methods, whatever they have provided. So if business has instance variables and retail business has separate instance variables, these will all be available to the Kmart. And you can access their respective methods as well. Again, if you have a method that's overridden by the retail business, and if you override it further down, you will be accessing your own method. However, if this is not overridden and this doesn't override, it will access it from business. So this structure is pretty simple, and it will be available to all the children of the classes. And this is an important fact. There is no single class hierarchy that's appropriate for all situations. So you have to look at the problem and then design your own hierarchy as it is reasonable as possible. So you have to look for the specific cases as case by case. And as we said, the hierarchy in Java, everything is basically based on the object class. So it is the ancestor of all the classes. Everything is generated from the object class. So whatever you implement in your implementation is actually an inherited class that is coming from object class. So object in the Java lang package gives you the object class, and then if a class is not explicitly defined to be the child of an existing class, it is assumed to be the child of the object class. So by definition, object class is the parent class of all classes in the Java implementation. So you have already you have already been using the certain methods of the object class, which are, for example, the toString method, which is basically the method provided by the object class. And whenever you write a toString method, basically what you do is that you override the toString method of the object class. So whenever we write the toString method, it's basically overriding whatever is provided by the object class. And so in the base case, if you don't, for example, define the toString method and just add the object at the end, it is going to return a string that contains the name of the object's class along with some other information. So if you, for example, try to, for example, here, let's say I'd like to, what's going to happen here if I try to system out print line, and if I give the object, for example, parked, As you see, it gives the name of the class and then some other, data that's not relevant to us, but basically it is calling the object's toString method in this object and executes it there. So that's, whenever you put any object, you can print it out, but it will just print something that is not really meaningful for your implementation. So always we try to write the toString methods in our implementations to have reasonable things printed on the screen, right? So you override the toString method of the object class whenever you write. Similarly, you have the equals method that's available in the object class. What does the object class may check for the equals case? It basically checks whether they point to the same reference or not. So that's the main check that is done. However, in string class, how do we check equals? Whenever it's overridden, we have the strings basically compared one to another, one character by one character, right? So this is basically the string class overrides the object class's equals method and implements it differently. So whenever you implement your equals, you implement and override the object classes or equals method as it is done with the string class. So abstract class, what's an abstract class? It's basically not exactly an empty class, but provides an abstract way of defining things in a class. So in this case, it's a placeholder which tells what are the different portions that might exist in the classes that you are going to implement as an extension to this class. So you use the abstract modifier and public abstract class product, which is going to give you an abstract class of product, and you can have the contents such as the instance variables and certain methods. This is different from interfaces. If you remember, interface was an abstract method by default, and all the methods were abstracts. What we mean by abstract method is that you only have the definition of the method, but no internal implementation has been identified. So that's the abstract method. However, in abstract class, it doesn't have to have all the methods as abstract. So it can have non-abstract methods. What we mean by this is that some of the methods can be implemented. However, some of them can be left off as abstracts. So, for example, there should be an example here, or I will write one. So if, for example, we would like to consider the interfaces, if you remember, so let me write one interface here. So let's say matter. So I would like to have a matter interface. How do I define? Public interface, right? And then I have a matter, which is basically going to be the name of my interface. And then if I would like to have a method that returns me the volume of a matter, for example, I have a cube or a sphere or any kind of shape, I would like to return the volume. So I could have a, for example, double, right? That returns me the public double, right? Get volume, which basically is all the definition I have. And then also I have, for example, public mass, for example, get mass. And this will, be the interface that I define. And here, these two methods are abstract methods. I forgot to add the implementation here, right? And so you have the mass and the volume that are defined as abstract methods. However, I don't have any implementation that is, detailing its details. If I want to implement this, if my class is going to implement this, what it is going to do, it will basically write how this volume and mass methods will be implemented. However, in abstract classes, if it is not an interface but an abstract class, what you do is that, let's say one of the methods here can have its internal definition. In this case, I will have, instead of interface, what will I have here? Public abstract class, right? Class method. And then in this case, I will have the get volume, which is going to be basically left empty. And then I will add, let's say, get mass, which can return something here. So let's say return 1 just for now, which returns 1 as a result of this method call. So basically, in abstract methods, not all of them has to be, in abstract classes, not all of them has to be abstract, but in interface, all of the methods must be abstract. That's the difference. So I will give a detailed example about this class, method class in the next lecture.
Boş olan metodu abstract yazmaya gerek yok mu?
Yes, you have to write. So you have to write abstract if the method is not really implemented, and if it's an abstract method, you have to include that there too. So if you go back to the slides of the abstract class, let me go there. An abstract class often contains abstract methods with no definition, like an interface. However, unlike an interface, the abstract modifier must be applied to each abstract method, as your friend notified. Also, an abstract class typically contains non-abstract methods with full definitions. So you can have fully defined methods in the abstract class. And in abstract classes usages, how are we going to use the abstract class in implementation? So if you remember, we use implements for interfaces. Right? Whenever I would like to implement an interface, I use the implements keyword. If I would like to use an abstract class, how am I going to use that abstract class in my implementation? It's basically a class, it's not an interface. So the usual way of accessing it is how? To basically using extends, right? So I'm going to extend this abstract class in order to access its features and its methods. So I'm going to use it as a base class, the abstract class as a base class, and use the extends keyword to implement its methods as I would like to, change some of the features there. It doesn't have to contain abstract methods. So if you don't define it as abstract, you can it will be implemented. However, if you define it as abstract, if you want to define it as abstract, you will add the keyword abstract to the method to indicate that it's an abstract method. So if you have a child of an abstract class, you have to override the abstract methods of the parent, or it's going to be considered abstract as well. So if you extend this abstract class, you have to implement those methods in your class. Otherwise, it is going to be also considered as abstract method. And then you are not supposed to use final or static, since they're abstract definitions. So the idea of having abstract classes is because you would like to have a base implementation of the classes and then use the features that are available already, that's common to all the things. And then for the not so common things, you implement additional stuff. Such as, for example, if you have, I will give that example in the next lecture, as I said. So if you have a matter object that you are using, and then from this matter you have a cube matter or cube object, and also a sphere matter. So normally, if you know the density of the matter, right, and the volume, you can compute the mass, right? So once I know the density and volume, I will be able to compute the mass. If that's the case, I can apply this to the matter as a method such that I will compute using the density and volume to get the mass. However, for volumes, this cube method and then the sphere method will have separate implementations. So I will just use the available mass method that is available from the matter abstract class that is going to use the specific volumes of cube and specific volumes of sphere, so that I will be able to compute it in the same fashion. And in this way, I will not have to implement this get mass and get mass separately here as two different methods. However, I will just move this as an abstract method and move it here. That is going to be implemented within the abstract class, so that both of these classes will be able to use that base class. However, for their volumes, I'm not going to implement the volume in this class. I will implement them separately for each of these, since they're totally different. Okay? So I will go into details of this in the next lecture after the break.